हेलो हेलो डियर फ्रेंड्स, आज हम पढ़ेंगे कुछ इंपॉर्टेंट से रिजल्ट्स, कुछ इंपॉर्टेंट थ्योरम्स जिसका एप्लीकेशन बहुत ज़बरदस्त है। ठीक है बेटे। सो ये जो रिजल्ट्स है ये कोलिनियरिटी चेक करने के लिए यूज होते हैं कि वेदर द पॉइंट्स आर कोलिनियर और नॉट। ओके, सो देखते हैं हम लोग कैसे कैसे करेंगे। एक टर्म होती है हमारे पास सीवियन। सीवियन का मतलब क्या है? किसी भी ट्रायंगल में अगर मैं एक वर्टेक्स से कोई भी लाइन अगर ज्वाइन करता हूँ, कोई भी लाइन, इसे कहते हैं सीवियन। एक वर्टेक्स से इस कोई भी पॉइंट को ज्वाइन करेंगे, इसे कहते हैं सीवियन। अब मैंने कहा अगर मेरे पास ऐसी सीवियंस हैं जो कि कंकरेंट हैं, इसका बहुत ही इंपॉर्टेंट रिजल्ट है और रिजल्ट का नाम है सेवास थ्योरम। ओके, बहुत ही इंपॉर्टेंट थ्योरम है ये हमारे पास कि एबीसी कोई भी ट्रायंगल अगर है और मैंने कहा डी ई एफ कोई भी पॉइंट्स हैं सच दैट ए डी बी ई एंड सी एफ they are the concurrent lines and concurrent at a point P. मैंने क्या बोला? In any triangle ABC, if AD, BE, CF are any three concurrent lines concurrent at a point P, then there is a very important result, and the result says BD upon DC, that is this upon this, into CE upon EF, EA, that is this upon this, into AF upon FB, is always plus 1. Shocking. That is ABC is any triangle and AD, BE, CF are any three concurrent lines, then this upon this is equal to this upon this is equal to this upon this is always 1. So let us prove this result. Okay. So what I have done is I just draw the perpendicular. Get the height of the perpendicular. This is H. Okay. So what I am doing is let us take area of triangle ABD. Area of a triangle ABD is half of BD into H. Area of a triangle ABD is half of BD into H. So, an area of a triangle ABC is equal to half of DC into H. Okay. If I divide, so what I get is just cancelling half and H here. So, area of a triangle ABD. Now, from now onwards, for our convenience, I am using this notation. This notation means area, ताकि मुझे हर बार ना लिखना पड़े. Okay, so I am writing this notation for area. That is, if I write this as x, it means area x, area of the figure x. Okay, this bracket. So area ABD of this triangle is upon area of ADC comes out to be BD upon DC. This is also one of the important results. That is, if D is any point, then ABD, area of ABD upon area of ADC is equal to BD to DC. Is that clear? Okay. Now let us draw the perpendicular here once again. Let this is the perpendicular and the height be H1. Okay. This is the perpendicular. Let the height be H1. So what we get is area of BPD. Area of a triangle. This notation represents for area. Okay. So area of a triangle BPD becomes half of BD into H, half BD into H1, half base into height. Okay, and area of triangle PDC or CPD is equal to half of DC into H1. Again, area of a triangle CPD is half DC into H1. Now, if I divide, again what we get is cancelling half and cancelling H1. Area of a triangle BPD upon area of a triangle CPD, it comes out to be equal to BD upon DC. Both are equal. That is, we can have BD upon DC is equal to ABD area upon ADC is equal to area BPD upon area CPD. Hope it is clear to everyone. There is one important property of a ratio and proportion. That is, if A upon B is equal to C upon D, then this is equal to A minus C upon B minus D. Hope it is clear to all of you. You can prove it like this: A upon B is equal to K. So A is equal to BK, C is equal to DK. So A minus C is B minus DK. Cancel out, again comes out to be K. Okay. Similarly, this result is also comes out to be equal to A plus C upon B plus C. Okay, this is a basic property of a ratio and proportion, that is A upon B is equal to C by D. This comes out to be A minus C upon B minus C. This is also equal to A plus C upon B plus C. So I am using this property here now, this one. That is area of ABD upon area of ADC is equal to area of BPD upon area of CPD. It comes out to be equal to area of ABD minus area of BPD upon area of ADC minus area of CPD. Hope it is clear to everyone. So what we get is BD upon DC comes out to be equal to area of ABD minus BPD. That is we get area ABP. I am erasing this one so that you can easily understand the figure. I am erasing this one. Okay. The purpose is solved for using H1 here. So here what we are getting is BD upon DC is ABD minus BPD. ABD minus BPD, that is it comes out to be equal to area ABP. Okay. And here ADC, area of ADC minus area of CPD, it comes out to be area ATC. ACP or APC, you can see this. Okay. And for our convenience, I am taking this area as delta 1. Okay. The area of triangle APB I am considering as delta 1. Okay. And I am considering this as delta 2. That is area of triangle APC. Is that clear? I am considering area APB as delta 1 and area ACP as delta 2. And similarly, I am considering this as delta 3. Okay. Area of this triangle. Area of BPC I am considering delta 3. So that area of a triangle delta becomes delta 1 plus delta 2 plus delta 3. Okay. So that area of a delta stands for area of a triangle ABC. The whole area comes out to be delta 1 plus delta 2 by delta 3. So we are getting an important result, that is in any triangle ABC, if AD, BE, CF are the three CVMs, then ratio of BD is to DC comes out to be delta 1 upon delta 2. Is it clear to everyone? That is in any triangle ABC, if AD, BE, CF are the concurrent lines, concurrent means they are intersecting at same point P, then ratio of BD is to DC comes out to be area of delta 1 upon delta 2. Clear? Similarly, what we are getting is CE upon EF. If BD upon DC is delta 1 by delta 2, similarly CE upon EA. CE upon EA becomes delta 3 by delta 1. Hope it is clear? Okay. CE upon EA becomes delta 3 by delta 1. And AF upon FB. AF upon FB becomes delta 2 by delta 3. Okay. So we are getting these three important results, that is BD upon DC is delta 1 by delta 2, CE upon EA is delta 3 by delta 1, and AF upon FB becomes delta 2 by delta 3. So if I multiply these three results, let's see what we are getting is BD upon DC into CE upon EA into AF upon FB comes out to be equal to delta 1 by delta 2 into delta 3 by delta 1 into delta 2 by delta 3. And we can easily see here that all these will be cancelled out and it becomes plus 1. So we get a very important result if the three lines are concurrent, BD upon CA, CE upon EA, BD upon DC into CE upon EA into AF upon FB comes out to be plus 1. Hope it is clear to all of you. That is, if AD, BE, CF are any three concurrent lines, then this is called a Cevas theorem. Now we will derive some more important results based on this. Okay. Some of the results are like this. I am erasing this board so that I can derive some more beautiful results for you. till now we had derived in any triangle ABC, if AD, BE, CF are the three concurrent lines, we had derived Cevas theorem, that is BD upon BC into CE upon EA into A upon FB comes out to be plus 1. Okay. Now we will do some corollaries of this result. First result you can get that AP upon PD is equal to AF upon FB plus AE upon EC. Okay. That is, if ABC is any triangle and AD, BE, CF are three concurrent lines, then we can derive AP upon PD is equal to AF upon FB plus AE upon EC. So let us see how we can do this result. Okay. So you can see as in triangle ABD, in triangle ABD, you can see here as, okay, I would like to tell you one thing. Okay, you can do like this. I would like to tell you this thing, that if ADP is a triangle, for example, and P is any point, you can consider this triangle as this way. As ADP is a triangle and P is any point, what I would like to say is AP upon PD is area of APB upon area of BPD. Hope it is clear to all of you. I had derived earlier as well, because you can say as APB is half of AP into H, if I draw perpendicular here. Okay, APB is half AP into H, BPD is half PD into H, H and H cancel out, half and half cancel out, we get this result. That is, in any triangle ABD, if P is any point, then AP is to PD is equal to area of APB and area of BPD. Just okay. Hope it is clear to all of you. I am using this result here. Okay. Like in this way, I am considering ADB triangle. So AP upon PD. AP upon PD becomes area of APB upon area of BPD. Hope it is clear to all of you. I am considering this as a base. AD is a base, B is a vertex angle. Okay. Then AP upon BD is equal to area of this triangle is to area of this triangle. Okay. Now I am considering area of triangle ADC. Now here I am considering in triangle ADC. That is, in this triangle I am again considering AD as a base, C is a vertex angle. Okay. Again AP is to PD is area of APC upon area of PDC. CPD differences. Okay. Again in this triangle ADC, AP is to PD is area of a triangle APC upon area of a triangle PDC. Okay. Both are equal to AP is to PD. We know this result from the ratio proportion property, that is A upon B is equal to C by D, then this comes out to be equal to A plus C upon B plus D. If A upon B is equal to C plus D, then it comes out to be equal to A plus C upon B plus D. Okay. You can prove it by taking it is equal to K. Okay. So I am using this result now. It becomes area of APB plus area of APC upon area of BPD plus area of CPD. Okay. You see here APB plus APC. APB plus APC. It becomes delta 1 plus delta 2. Okay. APB is delta 1, APC is delta 2. Okay. Now BPD plus CPD. BPD plus CPD becomes area of a triangle BPC. BPD plus CPD becomes area of a triangle BPC, which becomes delta 3. Clear? Now we can write this as delta 1 by delta 3 plus delta 2 by delta 3. That is AP upon PD comes out to be equal to delta 1 by delta 3 plus delta 2 by delta 3. And in my previous theorem when I derived this result, we had used that delta 1 upon delta 3 becomes equal to AE is to EC. Okay, this becomes AE upon EC. Okay, delta 1 upon delta 3 becomes AE upon EC, and delta 2 upon delta 3 becomes AF upon FB. Hope it is clear to all of you. That is, we get an important result, that is AP upon PD. That is, AP upon PD becomes AF upon FB plus AE upon EC. Okay. Similarly, we can get BP upon PE. Similarly, we can get BP upon PE is equal to BD upon DC. That is this upon this plus BF upon FA. Cevas theorem can be used for concurrency as well. Okay, whether the lines are concurrent or not. And similarly, we can get CP upon PF. Similarly, we can get CP upon PF as CE upon EA. Okay, plus CD upon DB. Okay, hope it is clear to all of you. Now I will derive some more important results based on Cevas theorem. Second result is AP upon AD plus BP upon BE plus CP upon CF is equal to 2. We will derive this result and we will derive this result as well. That is PD upon AD plus PE upon BE plus PF upon CF is equal to 1. Okay, so let us see false proof of second result. AP upon PD, AP upon AD. AP upon AD becomes area of ABB. Okay, upon area of ADB. You can see here as APB and ADB. Okay, AP upon AD. You can see, if you want to see, you can see here as likewise. If this is A, this is P, this is D, this is B. Okay, area of APB. This is the H height. APB area is half of AP into H, half base into height. Area of ADB becomes half of AD into H. Okay, cancelling this, we can get AP is to AD. AP upon AD. This side upon total side becomes area of APB upon area of ABD. Hope it is clear to all of you. So we can use this result here. Area of AP upon AD becomes area of APB upon area of ADB. Now, if I see in triangle ADC here, AP upon AD becomes area of APC upon area of ADC. I am using this bracket for area. And again I am using this result. If A upon B is equal to C by D, then we can use that A plus C upon B plus D. Okay, so we can use this result here. That is APB plus APC upon ADB plus ADC. Okay, beta. Now it becomes APB is delta 1. APB is delta 1. This is delta 1 and APC is delta 2. Here ADB plus ADC. ADB plus ADC becomes or area ABC. ADB plus ADC becomes area for triangle ABC, which is delta. And we know that delta is equal to delta 1 plus delta 2 plus delta 3. So we can get AP upon AD. This is one of the important results. That is, if ABC is any triangle and AD, BE, CF are any three concurrent lines, and this side upon total side is equal to this area plus this area upon total area. Okay. Similarly, BP upon BE, BP upon BE becomes delta 1 plus delta 3 upon delta. Okay. BP upon BE becomes delta 1 plus delta 3 upon total area, that is delta, and CP upon CF becomes delta 2 plus delta 3 upon delta. Okay, so if I can add all these results, that is AP upon AD plus BP upon BE plus CP upon CF, it becomes 2 times of delta 1 plus delta 2 plus delta 3 upon delta. If I add all these results, since the denominator is same, so it becomes 2 times of delta 1 plus delta 2 plus delta 3 upon delta. It becomes 2 times of delta upon delta. I can cancel out this delta. So we can get the important result, that is AP upon AD plus BP upon BE plus CP upon CF comes out to be 2. Okay, easy. And for this result, third part, I am deriving right now. I am erasing this board. Clear? So this is for the third result, PD upon AD. That is PD upon AD becomes area of a triangle BPD upon area of a triangle ABD. PD upon AD becomes area of a triangle BPD upon area of a triangle ABD, and this also becomes area of a triangle CPD upon area of a triangle ADC. Area of CPD upon area of a triangle ADC. So again I am using this result, that is A upon B is equal to C by D. It comes out to be equal to A plus C upon B plus D. So this becomes area of a triangle BPD. This is one of my favorite results. I am using this result in many of the problems for pre-RMO. That is ABD plus ADC. Okay. When I give you the problems for area, then I am using this result frequently. Okay. So BPD plus CPD, it becomes area of a triangle BPC, and this is ABD, area of a triangle ABD, plus area of a triangle ADC, it becomes area of a triangle ADC. Okay, so what we get is PD upon AD becomes delta 3 upon delta. Okay, this PD upon AD becomes delta 3 upon delta. Delta stands for area of a triangle ADC, which is comes out to be equal to delta 1 plus delta 2 plus delta 3. Similarly, PE upon BE becomes delta 2 upon delta, this upon total, and PF upon CF becomes delta 1 upon delta. Okay, so if I add these results, what we get is PD upon AD plus PE upon BE plus PF upon CF. It comes out to be delta 1 plus delta 2 plus delta 3 upon delta. It comes out to be equal to delta upon delta, that is, which is 1. Hope it is clear to all of you. Okay. There is an important trigonometric form of a Cevas theorem. We can use that theorem frequently. That this which says, that is, if these are the angles, you can say this angle is alpha 1, this is beta 1, this is alpha 2, this is beta 2, and this is alpha 3, this is beta 3. Okay, the theorem states that BD upon sin alpha 1, that means the theorem states that sin alpha 1, I can derive the result as a sin alpha 1 upon sin beta 1, okay, into sin alpha 2, sin beta 2, sin alpha 3 upon sin beta 3 comes out to be 1. Very important result. Okay, this is very important result, that is BD upon sin alpha 1. Well, you can sin alpha 1 by sin beta 1, and sin alpha 2 upon sin beta 2, sin alpha 3 by sin beta 3 comes out to be 1. It can be derived by using the Cevas theorem. Okay, you can see as you can derive the result, this theorem, this result by B, which I done by the normal Cevas theorem, that is BD upon DC. You can use as a this upon this, this upon this, this upon this. They come in the ratio sin alpha 1 by sin beta 1, sin alpha 2 by sin beta 2, sin alpha 3 by sin beta 3. They comes out to be equal to 1. You can try, otherwise I will tell you the proof. Okay. So now I am discussing about Menelaus theorem. This is very important theorem. This is Menelaus theorem. it states that if ABC is any triangle, if ABC is any triangle, and if you can draw any line, which cuts AB, BC and CA at a different point. For example, you can say this is D, this is E, this is F. It is if ABC is any triangle, and if you can draw any line which cuts the three sides of a triangle at distinct point D, E and F, then there is one important result called Menelaus theorem, which is called AD upon DB, that is this upon this into BF upon FC into CE upon EA comes out to be -1. आप लोग सोच रहे होंगे कि यार ये -1 कैसे है? These are the lengths. Why I taken the negative sign? So I will tell you. Okay, I will tell you right now. Okay, if AB is a line segment, you can say of 10 centimeter. But AB is a line segment of 10 centimeter, and if C is a point such that this is 4 centimeter, this is 6 centimeter, so that AC is to CD becomes 4 by 6, that is 2 by 3. Okay, if AB is a line segment, C is a point, so that AC is 4 centimeter, CB is 6 centimeter, then AC is to CB becomes 4 by 6, that is comes out to be 2 by 3. Now if I take a point D this side, such that AD is 20 centimeter, and this becomes 30 centimeter, then AD is to DB becomes 20 by 30, it is again 2 by 3, but C is a different point, D is a different point. So for our sign convention, we use directed line segment. Directed line segment means in the same direction, as AC and CB are in the same direction. Okay, that's why we just take the sign as positive. यानी C वाला पॉइंट अगर इंटरनली कट करता है तो हम उसको पॉजिटिव लेते हैं, क्योंकि A से C पे गया, C से B पे चला गया, सेम डायरेक्शन आई, तो इसमें हम जो रेशो लेंगे ये वाला रेशो पॉजिटिव लेंगे. यहाँ पर क्या होता है, A से D पे गया, अगर हम यहाँ देखेंगे द डायरेक्शन ऑफ A टू D, AD इज दिस डायरेक्शन, ओके, और D टू B दैट डायरेक्शन इज दिस वे, direction is reversed. Okay, so directed line segment says we should take this ratio as negative sign. Okay, if you are changing the direction, you have to change the sign. Okay, that is why if a point C divides internally the line segment, then we take the ratio as positive. If a point D divides the line segment externally, then we can take the ratio as negative. So here what is happening is this ratio is positive, this upon this is positive because D is cutting the side AB internally, but this ratio is negative because BF is to FC. As the direction change, that's why we have changed the negative direction. But here CE upon EA is a positive sign. Okay, यानी कोई भी लाइन अगर मैं ड्रॉ करता हूँ तो होगा क्या, या तो वो दो साइड लाइंस को इंटरनली कट करेगी, इसको एक्सटर्नली कट करेगी, या तीनों को ही एक्सटर्नली कट करेगी. यानी मैं धीरे धीरे आपको इसका एप्लीकेशन बताऊंगा. फॉर एग्जांपल ADE में ट्रायंगल ले लेता हूँ. फॉर एग्जांपल मैं ADE वाला ट्रायंगल कंसीडर कर लेता हूँ और इसको मैं ट्रांसवर्सल मान लेता हूँ. ठीक है, तो ये जो ट्रांसवर्सल है AD को भी एक्सटर्नली कट कर रही है. अगर मैं AB अपॉन BD लिखूं, ठीक है, AC अपॉन CE लिखूं, उसको भी एक्सटर्नली कट कर रही है, और यहाँ पर इसको DF अपॉन FE लिखूं. ठीक है, तो उस केस में तीनों ही नेगेटिव 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 हो जाएंगे, फिर भी हमारा तो नेगेटिव आ जाएगा. समझे, नेगेटिव साइन जो है हमारे साइन कन्वेंशन के लिए है कि अगर इस पर्टिकुलर डायग्राम में देख रहा हूँ तो ये जो रेशो है पॉजिटिव आएंगे दोनों. ठीक है, ये वाला रेशो नेगेटिव हो जाएगा, इसलिए यहाँ पर साइन जो है नेगेटिव आया. ठीक है, हम इसका प्रूव करते हैं, आपको मजा आएगा. ठीक है बेटे. So what I am doing is I have just drawn the perpendicular here. I have just drawn the perpendicular. Okay, you can draw perpendicular here. You can name them as, let this be L, let this be M, and let this be N. Or you can name as, let this height be H1, this is H2, this is H3. Okay, as per your convenience. So let us see. In triangle ADM, and triangle BDM, in triangle ADM and triangle BDL, this angle is equal to this angle. This is 90, this is 90. Okay, you can say angle ADM is equal to BDL, vertically opposite angle. Okay, vertically opposite angle. And A and B is equal to BLD 90 degrees. Therefore, triangles are similar. Triangle ADM is similar to triangle BDL. Okay. So what we get is AD is to DB. I am just taking the sign. AD upon DB becomes AM upon BL. That is, I can take as H1 upon H2. Okay. AD is to DB becomes the ratio of the altitude H1 by H2. Okay. Now here you can consider the triangle BLF. Similarly, I can say BLF triangle is similar to triangle CNF. You can see here as this angle is common in triangle BLF and CNF. This is common. This is 90. This is 90. Okay. So what we get is BF upon FC. BF upon FC. That is BF complete side upon FC becomes the altitude, that is BL upon CN, that is H1 by H2 by H3. ठीक है बेटा? यानी BLF वाला जो ट्रायंगल है वो CNF वाले ट्रायंगल के सिमिलर हो जाएगा, तो BF अपॉन FC का जो रेशियो है वो H2 by H3 आ जाएगा, क्योंकि ये नेगेटिव है तो मुझे नेगेटिव साइन लेना चाहिए. ठीक है, साइन कन्वेंशन के लिए. ऐसे ही मैं कहना चाहूँगा इन ट्रायंगल you can say as in triangle AEM, in triangle AEM and triangle CEN. In triangle AEN and triangle CEN, they are similar because this angle is equal to this angle, vertically opposite. This is 90, this is 90. ठीक है बेटा, ये वाला एंगल इस वाले एंगल के बराबर आ जाएगा, ये वाला 90, ये वाला 90 हमारे पास. ये दोनों ट्रायंगल जो है हमारे पास AEM वाला जो ट्रायंगल है वो भी सिमिलर हो जाएगा CEM के बाय AA सिमिलरिटी. तो व्हाट वी गेट इज CE upon EA. Okay, this upon this is equal to CN upon AM. That is comes out to be equal to H3 by H1. Okay, बेटे. Now you can multiply these results. This one and this one. So when you multiply these results, what we get is AD upon DM into BF upon FC into CE upon EA. It becomes H1 by H2. This is minus H2 by H3. This is H3 by H1. So we can cancel out H1 से H1 cancel out हो जाएगा बेटे, H2 से H2 cancel out हो जाएगा, H3 से H3. It comes out to be equal to -1. Hope it is clear to all of you. ठीक है बेटे. So this upon this, this upon this, and this upon this is always comes out to be equal to -1. This is a very important result. Okay. We will use this result in quadrilateral as well. Okay, if you are having any quadrilateral, you can say as, okay, that ABCD is any quadrilateral, and you can draw any line. Okay, you can draw any line, or I will make a quadrilateral as per your convenience, so that you can easily get what I would like to say. It is if you are having any quadrilateral like this. Okay, ABCD is any quadrilateral, and if you are having any line which cuts the sides, any line which cuts the sides of a quadrilateral. Now this line cuts this quadrilateral at a point P, this at a point Q, this at a point R, and this at a point S. Okay, for quadrilateral the theorem states that AP upon PB into BQ upon QC, and this upon this, into CR upon RD, this upon this, into DS upon SA. Now it comes out to be equal to +1. it comes out to be equal to plus 1. For the proof of this, you can join AC. For the proof of this, you have just joined AC. Okay. Let this cut at a point T. Let it cut at a point T. So in triangle ABC, this is a transversal. So we can get that AP upon PB by using Menelaus theorem for the triangle. AP upon PB into BQ upon QC into CT upon TA. It comes out to be equal to minus 1. Okay. This upon this, AP upon BQ, AP upon PB, BQ upon QC, CT upon TA comes out to be equal to minus 1. And in triangle ACD, you can see as in triangle ACD. Okay. What we have is CT upon TA, or you can write AT upon TC. Now AT upon TC into CR upon RD, this upon this, CR upon RD into DS upon SA comes out to be equal to minus 1. Okay. Now you can multiply these two results. You can multiply equation 1 and equation 2. What we get is AP upon PB into BQ upon QC into CT upon TA into AT upon TC into CR upon RD into DS upon SA. It comes out to be minus 1 into minus 1 comes out to be 1. You can cancel CT by CT and TA by TA. We get the required result for a quadrilateral as well. Okay. That is, if a figure having even number of sides, then it is plus 1. If a figure having odd number of sides, then it comes out to minus 1. That is, if it is a pentagon, then it becomes minus 1. Because here you can see as this ratio is positive, this ratio is positive because Q and R cuts BC and CD internally, and P and S cut AB and AD externally. So these two ratio comes out to be negative. So negative become positive. These two ratios are positive. So if it is a pentagon, then the ratio again comes out to be negative. That is a polygon having n number of sides. If n is odd, then the ratio is negative. If n is even, then it comes out to be positive. Thank you.